Okay. And the very most important thing you've got to realize when we're adding, subtracting rational expressions, and this is the case if we're doing any kind of, and again, it's fractions. When we're talking about rational, that just means it's fractions. You have to have common denominators. Okay. So no matter what you do in this section, you've got to, if you have common denominators, we're good to go. But if you don't, then you've got to rework them. Now, and for this part of it, you don't necessarily have to write this down, but this is kind of the image that you want to think about, and this is kind of taking you back to, I guess, like fifth or sixth grade on this one. So, because you're not going to have a problem like this, but let me at least just kind of set it up for you. If you had something like 3/8 plus 5/12. All right. If you remember, this answer was not going to be 8/20. That just like we were doing this, way back when you first started doing fractions, you had to have common denominators. And what you had to do, there's a couple of ways you could do this one. Is that we're going to take the 8, the two denominators we have, we're going to break them down. All right. And you probably didn't do common denominators quite this way, but this is kind of the way we're going to do it because this is the thought process we've got to go through when we're doing these. More than likely, what y'all probably did, and then what most people did was they're like, all right, if it's 8 and 12, you just list off the multiples of 8, and then you just count them off until you do the same thing with 12, and then eventually you get to a number that they have in common. Well, for what we're going to do, it's not going to work that way because the numbers, we're doing rational expressions. So you're going to have x plus 2s and 3x squares and that kind of thing. So you're not going to be able to do that. You're going to have to kind of go more this way with it. So that 8, if you wrote it out, would be 2 times 2 times 2. 12 was 2 times 2 times 3. And one way you could have done this, and again, I don't know if anybody ever taught you this way back when you were going through these with fractions like this. One way you could get least common denominators back then to do this part is that you would tell me, all right, tell me what they have in common. Well, they have a 2 here and they have a 2 here. So we have 2 times 2. So that they both have a 2 in common here. They both have a 2 in common here. And then basically, once you figure out what they have in common and you've taken that out, you can then tell me, all right, what all's left over? Well, I've got a 2 left over up here, and I've got a 3 left over from the 12. And if you multiply all those things together, then that would tell you what your common denominator would be. All right, now there's probably a good chance that nobody ever showed you that. But we would use that to kind of build it to, because what we're going to do today when we start talking about getting common denominators is we're going to use that same basic concept. Okay, so if we rewrite this one now. All right, so here's where we're going to go back to like you would done before. So now we're going to take both of these fractions you have and rewrite them so they're both 24s. And this is where we're going to do the same thing you've done all those other times. For this particular fraction, on the bottom part, to get from 8 to 24, we multiply by 3. And if you multiply by 3 on the bottom, you've got to multiply by 3 on the top. So 3 times 3 makes that out to be 9. For this fraction, had to multiply by 2 on the bottom, so we do the same thing on the top to get it to be 10. And one other thing that we're going to do that, again, maybe you didn't quite do here, but for what we're doing process-wise is that once you've got these common denominators that's here, you're going to rewrite it, and then you're just going to write down whatever your numerators are, and then do whatever it says to do there. So 9 plus 10 would be 19 over 24. All right, and then if you got to the end, if you could simplify this one a little bit, you could, but in this case with 19 over 24, 19 is a prime number. There's nothing you can break out of the 19 to get it to something over 24. Okay. All right, so that's the thought process that you want to go to. You've got to find your common denominators by telling me what's in common and what's left over. Multiply that together to get your least common denominator, and you've got to rewrite the fractions. And then once you've got them rewritten, you change your numerators. Then you add or subtract whatever it tells you to do, and then you can kind of go from those. Okay, so that's with just regular fractions. Let's give you the steps if you're actually adding and subtracting the rational expressions here. All right, so step one, you've got to factor everything as much as possible. Okay, that's numerators, that's denominators. It doesn't matter what it is. You factor everything out as much as you possibly can. Mostly, again, denominators is the key part. Numerators, if you do that a little bit, that's fine. If you don't, it's still okay. But the main thing is you still got to factor the denominators, but you still go ahead and say you will factor everything as much as you can. All right, once you've factored everything as much as you can, you're going to find the least common denominator by multiplying what is in common by what is left over. Okay. And once we do a couple of these, I'll give you a shortcut that we can do for this section. So, but technically, a lot of times if we're moving on into pre-cal and you have to go back and work on rational expressions, this is what you have to do. But we're going to give you a little bit of a shortcut for what we're doing today. And we'll talk about that just a little bit later on after we've done an example or two. Okay. Step three, again, this is where you're going to rewrite the fractions. And this is one where sometimes I'll do this as like steps together because 3 and 4 kind of go together. We're going to do them separate here in this case. So you're going to rewrite the fractions using the least common denominator, and then you've got to change the numerators, or we're going to say we're going to multiply the numerators by the same thing you multiplied the denominator. So multiply the numerators by the same thing you multiplied the denominators by. Okay, so we've changed the denominators, we've changed the numerators. So then we're going to either add or subtract the numerators, whatever the signs tell you to do. So we're going to add or subtract the numerators, and basically at this point, and just put it over the least common denominator as one big fraction. So add or subtract the numerators, and write as one fraction. So basically, you'll take the two. Now that you've got the least common denominators, you can put those two things together, and you can basically make it one big fraction now. And that's what we're trying to do. Is we're trying to make this thing so it's one big fraction. And then once you make it one big fraction, you simplify, and then you factor and cancel. Okay, and those that simplifying and the factoring and canceling, all those are if possible. Sometimes once you've combined once you put it together, and you've rewritten everything, there's not any simplifying. There may not be any factoring, and there may not be any canceling. So sometimes, once you combine everything together, that's all you can do. Most of the time, it's not. Most of the time, there's quite a few things that you can do for this one. And the one thing I will kind of give you on this one is that when you do all this stuff that's here at the end, I ran out of room, so we'll just kind of put it at the top of the next paper here. I think the biggest mistake I've seen people make when they're doing these sometimes is that if you want to put an asterisk at the end of this one, because this is kind of the big one, is you don't cancel until the last step. Because a lot of times people will kind of cancel back in step 4 or step 3 or step 5. So they'll start to cancel somewhere back here, and then they'll be like, well, okay, well, then what do I do then? Because now I'm back to where I started from it. So this is one of those things, you don't do any canceling until you get to the very last step, and that's when you want to go ahead and try that one. If you cancel before that very last step, then things get messed up, and then you're not sure kind of what to go and where to go from there. Okay, so before we do anything at all with with everything here, we're basically just going to we're going to do the first 2 steps. We're going to do the least common denominator, and then once we've got that part done and we do practice on a couple of these, then we'll come back in and kind of add in the next steps that go with it. So we're not going to do all this in the first things on this one. We're just going to find out what the common denominator would be. So we're going to say that given denominators, find out what the least common denominator would be. So we're not going to worry about adding and subtracting and all these other things. We're just saying, all right, if these were the 2 denominators we had, what would the least common denominator be? Okay, so for this one, let's do 2x plus 4 and x squared minus x minus 6. All right. And again, everything that we're going to do, the very first step you do with any problem that you have here is you're going to factor everything as much as you can. So if we factor 2x plus 4, that one's just got a 2 in common. So divide out of 2 and make it 2 times x plus 2. Okay, so that one's got a fairly easy factor. This one with x squared, this is where we're going to start off with the factors of -6 that's going to equal -1. Well, it's not going to be 1 and 6. It's going to have to be 2 and 3. And since the b term is negative, the bigger number is negative. If you do -6 divided by -3, that makes the 2 out to be a positive. All right, and then to find out what the least common denominator is, it's just tell me what's in common times whatever you have that's left over. Okay, and what I'll do for this one is we're just going to kind of lightly shade out. Okay, so they both got an x plus 2. So in that case, we'll put in x plus 2 is what's in common. And once you figure out what they've got in common, everything else is left over. Well, that's, again, just the leftovers. You got an x minus 3 that's over here, and you've got a 2 that's here. So that would be your least common denominator of x plus 2 times x minus 3 times 2. And again, it doesn't matter where the 2 goes. If you put the 2 in front, that's okay. As long as you got an x plus 2, an x minus 3, and a 2, that's going to be your least common denominator for what's there. All right, let's do one more of these. And then once we've got this one done, then we'll actually go through and walk through and start adding and subtracting some of these things together. So let's go with x squared plus 3x minus 4 and x squared plus 2x minus 8. Okay. And everything, again, it's basically everything is factoring. So it's still factoring review. We were doing a lot of factoring yesterday. We're still going to do a lot of factoring today. The good news is almost all the factoring today that I can think of, the first term is going to be x squared, so it's going to make the factoring a lot easier. So when you factor this one, you know it's going to be x times something in both these parentheses, and then you just got to find what the factors of -4 are that would equal +3. And the numbers shouldn't be very big, so you won't have to go through a million different numbers on this one. Like for this one, it's either 1 times 4 or it's 2 times 2. Well, the only way to get 3 is it's got to be 1 times 4. And the b term is positive, so the bigger number is positive. If you divide -4 by +4, that means the 1 would have to be a negative. And with x squared, the factors of -8, that'll get you to 2. Well, that's got to be 4 and 2. Bigger number is positive. So if you do -8 divided by +4, that's going to make it a -2. Okay. And again, for least common denominator, just tell me what they have in common. What do they both have? Well, they both have an x plus 4. So if they both have an x plus 4, we're going to take that part of it out. And once you've kind of lightly scratched out what they have in common, tell me everything that's left over. X minus 1 in the first one, and an x minus 2 in the second. And all three of those things there would be what your least common denominator would be. And you do not have to do that. Don't worry about, some people always have to do, we have to do the full method on this one. No, leave it factored out just like that so that you don't have to, you don't make it any harder than you have to. Just tell me all the pieces of it, and that's all you got to do for common denominators. All right, so every one of the problems that we're going to do, that's the very first step that you do. It's factoring everything out. And when you're factoring these out, basically, again, you tell me what they have in common, and then you tell me what's left over. Now, here's kind of the shortcut for this section for what we're doing today. Basically, today is that you tell me everything that shows up in your denominators, and that's going to be what your least common denominator is. So we've got the x plus 4 that's here, the x minus 1, the x minus 2. Now, again, technically, you're supposed to do the common times the leftover, but pretty much anything that shows up in your denominators, those are the things you're going to list for your least common denominator. When you go into pre-cal, they'll make some of these denominators a little bit more complicated, and you have to dig into it a little bit more. But for what we do in Algebra 2, that's basically just tell me everything that shows up, and then you're fine there. Okay, so here's where we're going to go all the way with these. So we're just going to add or subtract. Okay, and that's going to be the directions. Just add or subtract. And it may say add or subtract the rational expressions. We're still just adding or subtracting. Okay, so we're going to have d minus 3 over 2d minus 1. We're going to add that to 3d plus 1 over 2d minus 1. Okay, and small steps on these. The very first problem we've got here, what I want you to notice is you've got common denominators. You've got the same thing here that you've got here. So everything is good. We don't have to worry about rewriting anything. We don't have to do any factoring. We've got common denominators. So this is where you're just going to take this problem and rewrite it as one big fraction once you got the common denominators. So then we're going to take the d minus 3. We're We're going to add that to 3d plus 1. All right, if you want to put a 1 in front of that, you can. And from there, you're just simplifying. You're combining like terms. You've got 1d plus 3d. And then you've got the negative 3 plus 1. And the good thing is that once you've got a common denominator and you've got it kind of here, you don't really have to worry about writing out what the fraction is. That basically, you just worry about working out the top, which will kind of speed the process up a little bit. So for this one, 1d plus 3d would be 4d. Negative 3 plus 1 would be negative 2. And even sometimes on these, when we're doing these problems, I'll just put, LCD at the bottom just because that's what we're doing. That once you've got these things rewritten as one fraction, you don't even worry about the bottom part. You just worry about the top part, that you do everything up here that you can possibly do. And we can do the same thing here. We'll just put LCD. Okay, so we've simplified it. We've combined like terms. We've done everything we can do. And then the last thing you want to do is you want to factor this thing. And you may go, well, there's not really a whole lot we can do. We can divide out a 2 from this thing. All right, so if we do that, that gives 2d minus 1. Okay, and now you've done everything you can do on the top. We've combined like terms. We've factored. We've done everything we can do. Now you can basically come back and say, all right, this was over 2d minus 1. And there's where you get to cancel, because now you've got 2d minus 1 over 2d minus 1. You can knock those out. So final answer for that question would be just a plain old 2. Okay, now most of these, when you do this, the answer you're going to get finished with is not going to be just 2 or 4. We're going to have, in this case, most time you're going to be left with like 2d minus 1 over 3d plus 7 or something like that. So, but that's just one possibility of what may happen. We'll keep doing 2 or 3 or 4 more of these just to kind of get comfortable with everything. And then we'll come back in tomorrow and work on it a little bit more, just because, to me, I think this is one where we need a little bit extra practice just to make sure we've got it. So, okay, so let's give you one where you don't have a common denominator. So let's go with x plus 1 over x minus 1. And we're going to add that to negative 2 over x squared minus x. All right, and again, we're going to factor everything as much as we can, which in this case, there's really not a whole lot of factoring you can do. The x minus 1 is just that. It's just x minus 1. Nothing you can do there. This one, there's just a little bit you can do. You've got x squared minus x. They both have an x in common. So if we take the x out for this one, that'll leave us with 1x on the inside. If you take the x out of this part of it, it's gone. But remember, technically, that is x squared minus 1x. So we do have to put a 1 in there for a placeholder. Okay, so finding out what our least common denominator would be then. All right, again, tell me what they have in common, which is the x minus 1s. And then you've also got to tell me what's left over, which in that case would just be the x. Okay, so now here's where we're going to take both of the fractions and rewrite them both as x minus 1 times x. And this one also is x minus 1 times x. All right, now, one thing you may want to do when you do these, once you've got these factored out, and sometimes people kind of do it this way, and we'll do it on the next problem, is that you may want to kind of think about, all right, if I'm going from here to here, well, what did I do to change this denominator to this part? Didn't do anything, right? That did nothing to it. So if nothing changed here, then nothing changes there. All right, but from this denominator, to get from here to here, we had x minus 1, we multiplied in an x. Well, if we multiply by x on the bottom, that means we've got to do the same thing on the top. We've got to multiply x times and then x plus 1. Okay, and on the next problem, what we'll do is we'll actually go ahead and rewrite the whole thing, because sometimes people get a little lost on this one because they're thinking about here. So this is one of those where we almost want to go back and have it written so it's like that, so you can see what it was that we had there. All right, so now we can make it one big fraction. And if you want to just put LCD, you can, because once you've got them rewritten with the common denominators, now all the work is in the top. And now it's x times x plus 1 plus negative 2. So x times x is x squared. X times 1 is 1x. And plus negative 2, well, that's the same thing as just a minus 2. Okay. And again, don't worry about the denominator, because we'll worry about that at the end. Once you've got the least common denominator and you've got the problems rewritten, you're done with the denominator to the very, very, very end, and we bring it back in. Now everything's all about the numerator. We've done the distributive property we can do. There's no combining like terms. So then once you're here, we're going to look to see if this thing will factor. So are there any factors of negative 2 that get us to 1? In that case, yeah, there would be. I'm going to run out of room here, so let me just drop that down here. So the factors of 2, which would be 1 and 2. B term is positive, so the bigger number is positive, which means the small number then would have to be negative. Okay, so we've brought it together as one big fraction. We've distributed properly. We've done everything we can do with that problem. We've got it factored out. Now you can actually bring back in that least common denominator of x minus 1 times x. And then now you finally get to cancel for, and again, the canceling should be the very last step you do. You don't do any canceling until you get to that very, very, very last step. Cancel those two out. And leave us with x plus 2 over x. All right, let's do 2 more of these, and then that'll wrap us up for today. All right, so we'll go with x over x squared minus 4, and then minus 1 over x minus 2. All right, and what we'll do for this one is we're going to factor everything out as we can, but we're basically just going to rewrite the 2 problems as they are. So the numerator, there's nothing you can factor there. It's good. Nothing you can do with the 1. There's nothing you can do with the x minus 2. The only thing you can factor is the x squared minus 4, and hopefully everybody realizes that that's the difference of 2 perfect squares. So if we factor that one, that's going to make one of them x plus 2. That'll make the other one x minus 2. All right, so again, for the least common denominator, you've got to tell me what they have in common. And this is where if you just kind of lightly scratch it out a little bit, you can still see it there. It helps out a little bit. What they've got in common is the x minus 2, and then tell me whatever's left over, that's the x plus 2. So that would be your least common denominator. Okay, now, and again, if you rewrite numerators and denominators, it helps out a little bit, because now you're going to look at it and see okay, if I rewrite both of these, then this is where you can kind of look at it and see what you changed for this one. To go from here to here, what I do extra on the bottom? Nothing, right? If you didn't change the bottom, then you don't change the top, so it just stays x. We've got the minus and the 1 here. And for this one, we went from x minus 2 to x minus 2 times x plus 2. So we multiplied in an extra x minus, or sorry, an extra x plus 2 on the bottom. And if we multiply by x plus 2 on the bottom, we got to multiply by x plus 2 on the top. All right. So again, if we were doing this one piece at a time, I think everybody would be okay that, okay, we factored and we've got it here. And then we figured out what they had in common. And then what do we do to change this one? What do we multiply by? What do we multiply by here? All right. So here's where we're going to bring it all together. And again, I kind of like doing it this way because it speeds it up. Because now I'm just going to put least common denominator. Because now that you've got the least common denominator and you've rewritten the tops, you just bring it all together. That it's x minus 1 times x plus 2. So that's negative 1 times x, and then negative 1 times 2. Still over the least common. And again, we're still not worried about the denominator. We're still just worried about the top numbers. X minus x is 0. If you do 0 minus 2, that's just negative 2. And with negative 2, there's nothing you can do with it. There's no factoring. There's no canceling. There's no nothing there. So then we'll just bring in that denominator that we had of x plus 2 and x minus 2. And then that will be our final answer that we're looking for. Okay, and I don't remember when I started switching out, just writing out least common denominator, but when we started doing that, it started to click with people that, okay, I don't do any, because sometimes when we would actually write out this least common denominator, they would start to try to cancel stuff and it would throw things off. So for these, once you've got the thing rewritten, just write down LCD to get to the very end, and then you look to see if there's anything you can cancel. So in this case, there wasn't anything we could do there. All right, one last question, and we're going to add one little thing to this one that we were doing yesterday that I don't think I have to do on a lot of problems. I might sneak it back in on one problem on these, but we'll at least show it to you so you've got some idea of what it is that's happening with it here. Okay, the only thing we're going to do different on this one is we're still going to simplify, which this case is adding and subtracting, but we're also going to state the excluded values. And the good thing is that for excluded values, the only thing that's just your least common denominator equal to 0. So you're not doing anything. Well, the only thing you do different is that you still go ahead and add, subtract, just like everything else we were doing. And at the very end, you just take everything that's in your least common denominator and set each piece equal to 0. So it's just one extra little step at the end. But as far as the work you do, it's not really adding anything to the problem itself other than just that one little piece of it. All right, so here we go. So here's the problem. We'll do 3x over x squared minus x minus 2 minus 5x over x squared minus 3x plus 2. Okay, again, just factor everything as much as you can to start with. Top part, nothing you can do there. It's 3x. For this one, if we factor off the denominator, which is where you're going to do most of your work anyway, we need the factors of 2. Well, on factors of 2, 1, and 2. B term is negative, so the bigger number is negative. And if you divide negative 2 by negative 2, that means that the 1 will then have to be a positive. Okay. This one, also the factors of 2. So again, we're looking at 1 and 2. B term is negative. So the bigger number is negative. And if you divide positive 2 by negative 2, it's going to make it a negative 1. All right, so least common denominator. Just, and again, basically, here's what you can do. Tell me everything that shows up in your denominators. We've got an x plus 1. We've got an x minus 2. You've got an x minus 1. And again, it's not technically correct, but for this one, we've already had the x minus 2 that was here, which was our common part, so you don't have to list it again, because that would have been the common part here and here. So that was what we had in common, and then the other stuff was what we had left over. All right, so we've got to rewrite everything with the least common denominator first. So it gets us here. All right, and then it just becomes, all right, we already had the 3x that was here. What do we multiply in extra to get from here to here? We put in, what, an extra x minus 1. So if we did x minus 1 on the bottom, we're going to have to do x minus 1 on the top. The 5x was already here. And for this one, to get from here to here, we're going to go around this one a little bit. To get from here to here, we had an extra x plus 1. Yeah. So if we multiply by x plus 1 on the bottom, you've also got to multiply by x plus 1 on the top. Okay, now again, the easiest thing to do is once you've rewritten the tops and the bottoms and you've got all this stuff here, on the bottom, just put LCD, because that way you're not going to try to cancel anything out, because before you can cancel everything together, you've got to get the top part simplified as much as you can. And just bring the top part down like it is. And if you've got just written the LCD on the bottom, now you're not focusing on the bottom. All your focus should be on the top. So now you got to work out all this stuff that's up here. So we've got to do 3x times x to get 3x squared. We've got to do 3x times negative 1 to make it negative 3x. And here's where you got to be just a little bit careful, because it's negative 5x times x, which would be negative 5x squared. And then negative 5x times 1, which would be a negative 5x. Still over the LCD. Again, we still don't care what the bottom is because we're working on the top. Okay, and on the top, now we're combining like terms. It's 3x squared minus 5x squared. That's negative 2x squared. Negative 3x minus 5x would be negative 8x. Okay, and still got one more step to do before we do anything else with the bottom. We've got the negative 2x squared minus 8x. This is where you have to factor this thing out as much as you possibly can. They're both negative and they're both even, and they both have an x, so we can take a negative 2x out of both of them. If we take negative 2x out of this, that'll leave you with one of the x's. Take negative 8 divided by negative 2, that's going to leave you with a positive 4, and then you're going to take the x out, so that'll leave you with negative 2x times x plus 4. And that, that's where once you've done everything you can do in the top part, we've done distributed property, we've combined like terms, we get to the very end of it, and we've factored it out. Now you can bring back in our least common denominator, which was x plus 1, x minus 2, and x minus 1. And then you look to see if anything would cancel. In this case, nothing cancels. So that's going to be your final answer. Okay. Now, and most of the time you do get something that cancels, but occasionally, like with this one, you don't get anything that cancels, and that's fine because it's 50-50. Maybe, maybe not on the canceling part. And then the last thing we've got to do is we're going to exclude whatever our least common denominator was equal to 0. So that was x plus 1 equal to 0, x minus 2 equal to 0, and then x minus 1 equal to 0. Okay, and again, they'll probably just give you a box with x not equal to, and then you'll just solve each one of these. So this one, x will be -1. This one will add 2 to both sides, and then this one will add 1 to both sides. So -1, +2, and 1 would be our excluded values.